the lesson today will not be on your quiz tomorrow. It will be on your quiz on Wednesday. Okay, so we're going to talk today about solving quadratic inequalities. So we're on page 68. Now, what we did last were linear inequalities. So I asked you what linear meant, and doesn't have an x squared, doesn't have an x cubed, it just has an x. So y equals mx plus b is the equation of a line, so anything with just an x in it is linear. So you're going to do this for quadratic inequalities. So we're going to start off first. Let me put this up here. Big note. You will see this a lot. I made my point moving forward. It will be on your test in May. Maybe multiple times. It's not hard. Okay? And I'm going to give you lots of notes today, but it's going to move. The notes will be long, but the problems will move quickly. So the first type of problems that we're going to tackle are the already factored. Okay, if you look at the top at example 5.3.1 at the top of the next page, 69, they ask you to solve this. And I'm going to put it all together for you in a little bit, but we're going to get through solving it. I think I'm going to stand up here so I can write a little neater. Okay, so step one is you want to determine or solve for your roots or zeros. By the way, a little side note is it should always be 0. 0 must be on one side. If it's not, we have to move everything over. Okay? So in this case, in step one, what are my roots or zeros? X equals what? And 4. Now, the next thing we're going to do is we're going to make our sign chart. Okay? Start off like a number line. So I'm going to draw this. I have 2 roots, so I have 2 little tick marks. Now, what would be the tick mark furthest to the left? 2. And what about the one furthest to the right? Okay. So we're going to treat this as if it is a number line. Now, what I want y'all to notice is I want you to notice 3 sections. Okay? If you've got color pens or pencils, you might want to pull them out and use those. So step 3, use a test number in each section to determine, that's section, to determine the sign. And by sign, I mean positive or negative. So everybody take your calculators out. Now, if I'm looking at this and I'm looking as if this is a number line, I want to test a number that will be in the green. What pretty easy number will be in the green? 1. So store 1 as x, and you want to type in x minus 2, x minus 4. You want to type in the original problem as it was written. Now, I do not care about the number. I care about the sign. What was the sign here? Positive. Okay? Now you're going to do a test of a number between 2 and 4. Some of mine last period wanted to do 2.136578, whatever. Knock yourself out, I don't care. 3 would be a great one. We do not want to do 2 or 4 because we're going to get 0. And guys, 0 is neither positive nor negative. So if you get a 0, try another number. What did I get here? Negative. Okay. So check a number that is to the right of 4. What'd you get? Okay. Doesn't always happen this way. We're going to do things, we're going to take this sign chart, we're going to, of course, use it for different things later on. So always check it. Don't ever assume that it's going to be alternating. Okay, so step 4. Look at the original inequality. Okay. If it is greater than or equal to or greater than, you want positive. Does that make sense? If it's greater than 0, if it is set greater to 0, we want the positive numbers, right? Yes? If it is set less than or equal to or less than 0, we want the, what numbers are less than 0? Negatives. Now, what did my original have in it? A less than. So what part of my sign chart am I wanting? The negative parts or part. What is that? That is 2 to 4. Now here's how we write it if it's between. Do you see that my negative is between 2 and between 4? It was a less than. Less than means and. Ands go together or go apart? Together. So it's going to be 2 is less than x is less than 4. That is your answer. Now, let me just throw this one at you. If you had x minus 2, x minus 4 is greater than 0. So here's just a little different scenario. If that was greater than, greater or. Yes, ma'am. Hey. What? Beecher, Pena, and Benninger. By Pearson. Addison Wesley, I think, is the publisher. Well, I don't know, can we get two classroom sets and just order about 65? And see if we can just get rid of these, if they're not compatible, get rid of these and order two classroom sets. I mean, we were looking at that, all these anyway, so they're compatible, but things like I would take.
Where are those don't go really well?
Can you send me that ISBN number? I'll look it up later. All right, thank you. Bye-bye. Okay, so I'm doing the same problem, but this time I have a different inequality. It's saying greater than. So, I want which signs? The positives. So in this case, I want this section and this section. Greater means or. Ors were written together or apart. Apart. So which section does this show me? X is less than 2 or X is greater than 4. And if those had equal to's under them, you would put equal to. You just follow suit. So what questions do you have about solving using the sign chart? We're gonna do a couple more of these, but any questions so far? Okay, so let's look at the next one. Oh, let me explain to you what's happening here. All right, that's your inequality. That's your equation. That is your quadratic. It looks something like this. You've got a root at 2. You've got a root at 4. It does something like that. So I'm explaining to you how all this fits together. So, if y has got to be, what was our first part, less than 0? If y is replaced with the less than 0, what section of this is less than 0? On the y, right? Everything from here down is negative. And this is the part between 2 and 4. Does that make sense? When I changed and wanted the greater than zeros, that would mean this part here and this part here. I want you to understand. So what happens if we have it upside down? Now which parts are less than 0? That part, the less than and the greater than, and the part positive is between. So it all depends on if it's a downward facing U or an upward facing U. But I want you to see, you do not have graphers, so you have to understand this at a little more of an in-depth level than just throwing it up on the grapher calculator and looking at it. So that's what's happening here. A couple of other things. Let me go over these real quick before we do another example. Write this one down. So if you see one that has imaginary roots, your calculator will likely give you a weird answer. It'll have like a plus something I, be long possibly, or it'll look like A plus BI is the format. It could be long, it could be 2 plus 3I, for example. Okay. What would I know if it had it set greater than 0? What would I know about that? What if it had that greater than 0? What about all the x values? They're all positive. So that would be true for all values of 0. I'm sorry, all values of x. Sorry about that. Okay, so if I had greater than 0, that would be true for all values of x. What if I had this and it came up and asked you less than 0? Do I have any part of that graph that is less than 0? That's negative. So what would my answer be? What? Or in the terms of it written like this, it would be false for all values of x. So not all your quadratics go through your x-axis. All right, let's work on another one. I'm going to give you this one right here. X plus 1, 5 minus x less than or equal to 0. So your first step was what? Reading off your notes. Find the roots or the zeros. So go ahead and tell me what x is. Write it down on your paper. Okay, what are my two roots? -1 and 5. Any questions about how I arrived at the roots or the zeros? Now what was step 2? Make the number line. How many roots do I have? 2. So I'm going to put 2 marks. Which one's going to go here? How do you know? It's the furthest to the left. And then 5. How many sections do I have? 3. So I'm going to test a point in that section, and I'm going to quit coloring these after a while. I'm going to test a point in this section, and I'm going to test a point in this section. So go ahead, take out your calculators. these signs am I most interested in? That tells me less than, which tells me the negatives. So I'm interested in this section and I'm interested in this section. So my answers would be, now this looks like less than and, but it's not, because this is actually an upside down U that goes through -1 and 5. Okay, so this would be x is less than or equal to -1, or x is greater than or equal to 5. Now that we've done a couple, what are your questions? Okay. I didn't know she had done it, but I thought we had done it last year.
almost everything in the services class. Like I wish I took it last year. I took this class last year.
Oh,
For STK.
yeah. Okay, so what I want you to do right now is turn to page 71, and I want us to look at 3A. Now read the instructions. It says use an algebraic method to solve the following inequalities. Leave irrational numbers in terms of surds. Surds also mean square roots. Okay? Some inequalities may be true for all values of x, others for no values of x. Okay, so what can we use at our disposal to find the roots of this? Polysolve. So take your calculators out and do polysolve on this. And we're going to use this answer, but we're going to talk about why it's not the appropriate format. Give me 2 decimal or 3 significant figures is fine. Okay, so what are my 2 roots? 4.19 and 1.19.
Oh, it's negative.
Okay, negative. Thank you. Okay. Are those rational numbers? No. What did my instructions say? Leave it in surds. So what does that mean I've got to do? Because that won't convert to a fraction. Because it's not rational. If it was rational, it would have converted to a fraction. So what's my only other option, really?
Square it. And leave it in square root of 1.
What can I use for that? Get out your formula sheet. Tell me what you think you can use to leave that in the form of a surd. Hard. The what? Not the discriminant. The whole quadratic formula. Remember, guys, another way to solve the quadratic equations is a quadratic formula. So you're welcome to leave it out and look at it. You're welcome to use it on any test or quiz, but it states opposite b plus or minus square root b squared minus 4ac all over 2a. The easy thing to do is polysolve. But if they want that in terms of a surd, something with a radical in it, then we have to do the quadratic formula. So let's start. What is my b up here? What's the sign of 3? So opposite b will be -3. Plus or minus square root 3 squared minus 4ac all over 2a. Write that down and do nothing until you get that written down. Quadratic formulas will solve any quadratics. Now, what I want you to do at this point is, because this is not going to come out to be a nice, neat little number, we know it's not, take your calculators and do that part only. Leave off the square root. Did you get 29 as your discriminant? Okay. By the way, 29 is greater than 0, equal to 0, or less than 0? Greater than 0. Do I have 2 roots, 1 root, or no roots? 2 roots. Okay. We always are going to loop back. Now, this is how they want their answer. But this is the easy way for me to do my number line. Does this mean one thing to you? No. In this form, does this mean one thing to you? You don't know what shows up where on the number line, right? But we can put the sign chart right here. We can do -4.19. We can do 1.19. But the next thing we have to figure out, go ahead and do your 3 points. Go ahead and do your 3 test points. Okay, I believe it was this. Am I correct? Okay. So, the only problem is they want my answer in surds. And am I looking for the positives or the negatives? Okay, so that means I want this section and I want this section. But they don't want x is less than -4.19 or x is greater than 1.19. They want this version. So I have to figure out which one of these is the negative. How are you going to do that? Yes. So the first time you're going to type it in. Everybody do this now. -3 plus square root of 29 over 2. And tell me which one that went with.
That just gives us square.
You can do hit the bottom down, hit that at the enter, and it should convert it. So which one was that? 1.19. So I can substitute that in right here. Oops. And this one has to be the minus.